So here I need to write here node hyphen name colon space, and what is that? IB hyphen node. Okay, now let's go and save. Once it is saved, it will show as edited. If it do have any problems in it, it will show as no change. And if I do kubectl get pods, and now it is in the running state. You understand the node selector now? Okay. Now get pods hyphen o wide. Can you tell me in which pod it got created and which node? D1. Which one? D1 is the one which you have edited or not? Now my two pods are getting created in the D1. Did it created in B1, BF here? No, because it doesn't has the label name there. You understand the concept? Online. Understood, Anna? Yes, you can edit two nodes and give the two different names. Dinesh, is it good to have the same label names for two different nodes? No, you need to have a separate different names. And in the manifest file, whichever the node name that you have given, the pods will go and schedule in that particular node. Understood? One more, yeah. If we have multiple worker nodes. Online clear? Okay. So let's delete that first. So kubectl delete. What did we? That's a reason. Node selector. What is that? Node selector. Should we go and delete in node selector here? kubectl delete hyphen f. Which one? Node selector. Deleted IB deployment. Yes, correct, Dinesh. You understand the logic, Dinesh? These two pods are routed to the first worker node. Why it routed to the first worker node? Because we have given the label there. In the manifest file, we have given the label called node name id hyphen node, and we have given the name to the first worker, routed to the first one. Did you route it to the second one? Okay. That is called node selector. Okay. So I just gave everything here, how to do and everything. Now let's go to which one here? Node affinity. Say that, Anna. Node affinity. What you need to have in your mouth. What is that name? Node affinity. So node affinity is a more expressive way to specify rules. Unlike in node selector, did I specify any expressions there? If not, if no, no, nothing. It's a directly node selector. Yes, that I told झुकेगा नहीं सारा directly label है नहीं बस. Okay, so but here node affinity is not like that. It is like me, humble. It's okay. Okay. Otherwise, go chalte raho. So that's how my stuff will be there. But yeah. So node affinity has two things. I told you, one is preferred, another one is required. Required meaning what? Must happen. It should must happen. Same like a node selector. Another one is preferred meaning good if happens. Good if happens. Otherwise, okay. Parts you go and schedule it on another worker. It's okay. No problem. That is preferred and then required. So, and this node affinity syntax supports in operators. What are the operators here? In, not in, exist, does not exist, greater than, less than. All these things will be there in the node affinity. But do we have in the node selector? No. That's a difference between node selector and node affinity. Okay. So here, how much depth I have given? See, we will create one manifest file for what? Node affinity preferred. And we'll have for required also. Let's see. Required, I don't know whether I put it or not. Required also I put it. So here, let's go preferred. Guys, do not worry about the code inside this. No, you no need to worry that at all. Okay. VI, which one is that? Preferred dot YML. Okay. On the top, everything is fine. Everything is old one. Deployments, blah, blah, blah. So come down and try to see something from here. Affinity. Try to read it. Try to understand it. How many replicas? Only one. See it. You understand something here? Huh? See here. Affinity. Say that. Under that we have what? Node affinity. Inside that, which one I'm using? Preferred or required? Preferred. Rest everything is same. Preferred during scheduling, ignore during execution. The syntax will be the same. If it is required, it will be here required. Forget about weight. It is the preference and weightage. And preference is what here? Match expressions. What is that? Key is equal to which one? Node name operator in. Which one here? MB hyphen node. But our node has what? IB hyphen node. But I'm putting here what? MB node. Now if I run this, you tell me pod will create or not. Bagav dimag ko. I can see virtually your brains are flashing from your heads. Tell me. Online, tell me, node will get created or not? Let's go with the logics. I'm using node affinity, yes or no? Inside that, I'm using preferred, required. Preferred. Preferred meaning what? It's okay. It's okay meaning, will it take it seriously? Will it take it seriously? That means pod will create or not? That's a logic. So it is clearly we are putting node name as MB node. First, this will go and check. Hey, MB node, are you there anywhere? No, worker nodes will respond. One worker node will able to see, but that is MB IB. Which one is that? Another one, no label at all. It is just keeping quiet. That's it. But our scheduler is the guy who is shouting. Scheduler is shouting, hey, anyone is MB node? No one responding. Chalo, hey pod, you go whichever, wherever you like. That is called preferred. That is called what? Should we go and check it now? Yeah. Save it. Tell me. kubectl apply hyphen F. Which one? Preferred. So kubectl get pods. Pod got created now. So let it create. Running up. Okay. So hyphen O. You're interested now, huh? Where did it created? In the D1. In where? In IB node. It created in where? Actually, we have given MB node, but it created in IB node. That is preferred. First, it will check is there or not. Otherwise, pod scheduler will go and Babu, whichever you want, you go just go in and I'm putting it in. Go and enjoy. Understand? Okay. Now, if I Okay, let's delete it first of all. Command kubectl delete -f preferred. Now, if I do vi preferred, now here I put here, which one? IB. Which one here? Now tell me where it will go now. It will go directly into that IB node or not? So it should go with the DF or not? Let's do kubectl apply. Where it went? D1? Because it is matched or not? It's matched. You understand the preferred? Let's go with that Jukagana salad. Which one? Required? Okay, let's delete this first. Okay. So if you go to the required, the only thing here is change. Yes, here both nodes are same. Yes, you are missing the Dinesh logic. So what is the preferred meaning? It will try to match the label. If it matches, directly it will go there. If it doesn't matches, it will pick up anything. That anything can be anything. Yes or no? I have two nodes. One node I have given IB node. But in manifest file, I have given MB node. And that is preferred. I ran it. Now, scheduler will go and check. Hey, MB node, are you there? No one responded. Then the scheduler go and put it in whichever node it like. And it has put it in the IB node. It can also put it in another node also not. It's up to the scheduler. Apan kaun hai? Yes or no? Okay, so let's go with here required. Dinesh, understood? VI, what is that? Required dot. And what it has? What node name? Huh? What node name it has? MB node? Do we have MB node? And what I mentioned here? What will create a? What will create a? Logically, it should not create. Right? Logically, it's not create. It will be in the pending state. Let's see. So, kubectl apply -f required. kubectl get pods -o right. Our scheduler has assigned anywhere, any node, any nominated node here, any node here, none. Why? वो झुकेगा नहीं साला. That is required, meaning if it has matching label, then only it will go. Otherwise, it will not go. मरेगा तो भी नहीं. Understand the clear differences? Node selector, node affinity, preferred, and then required. Right? This is how you need to tell in interviews also. If they ask about the differences clearly, but don't tell झुकेगा नहीं साला. Right? But if you tell also, you will. It is really funny. He'll understand, right? That much depth concept you have, right? Nice. So let's go and delete it, huh? kubectl. But if I go and edit IB, you can label it the other node as MB node, and this will go there. Obviously, this will go there. Okay. Which scenario we will go for in project in real time, or this concept? Let's say, for example, you have movies. You have movie spots, manifest files. Everything related to the movies, I want to go to the one node. Can we use? Which one I need to use in this case? Required. Or go with the node selector. Node select is the old one. or else go with the node affinity. In the node affinity, which one you go for? Required. All the movies I want, group it. Particular application, you can group it or not? You can group it. That is one thing. And then you can also mention that machine learning ML applications need to go to that particular worker node because that bloody worker node has a lot of memory and CPU. Can I rewrite them there? Yes or no? So like this in real time, we'll go. Okay, Dinesh. Okay. So what is the last one on here? Highlights. What's that? Taints. Okay. What is that? Taints and tolerance. I think you should speak up louder. I cannot hear probably. Taints and tolerance. Okay. Okay, so I'll give the same example here. Taints and tolerance is the old method. People now also it's okay, you can use it. But I have given one small examples here. Is it possible two nodes can have the same label name? Yes, you can have, no issues. Okay. So in Kubernetes, taints and tolerance work together to control the scheduling of pods onto nodes. Taints are applied to whom? Nodes. And then this tolerance will be created inside the pods. Taint should be applied on nodes. Tolerance will be inside the pods. Remember, taints for nodes, tolerance for pods. So what I do is, example scenario I gave this, dedicated nodes for specific workloads. All machine learning applications or mainframes or any particular separate category. Can I taint it to one node? Taint is nothing but label only. Taint is an old method. Node affinity is a new method. Concepts are same. Right? Taint is like a label. So whenever there is a label, you go into it. Whenever there is no label, don't go it. It will not schedule it. Simple as that. Schedule, don't schedule it. So taints mostly will use for no schedule. You can use no schedule, or if you want to schedule, give a nice taint name. Okay. So for example, our so-called master guy, which one? Master. Why pods are not creating in the master? It has a taint. It has what? It has a taint. Should I show you? That's the reason why that boss is not taking the pods. Our scheduler in the starting creating at the cluster time also, I think this master node has given bribe to scheduler. Hey scheduler, अपन तक नहीं आना. Pods, उधर भेज दो. Yes or no? Then scheduler will put one small match fixing will happen. No? So taint, one small taint. Then cube scheduler will never go because there is taint. If I remove the taint, chalega master pe. Right? Okay, see here. Now what's the command to edit the node? So first of all, get the nodes. kubectl, get nodes. Okay, kubectl, edit. Which one? First one, master node. So I need to put a node name, right? Node. And then if you go here, do you see this? What is the effect? That is the reason why in the master node, pods are not scheduling. This is an interview question. So in interview question, they'll ask, does the pods are scheduled on the master node or not? You will say clearly no. What is the reason? Then you should say it has a taint effect. What is the effect? No schedule. Whenever you put no schedule, our scheduler will never run the pod onto that particular node. So here in the master node, we have here, but in the worker node also, if I taint it saying that affect no schedule, will the scheduler will create any pod into that? No. Then I can do my maintenance upgrade activities there on that node or not. Then I'll remove the taint, and then scheduler will start putting the pods there. Got it? Understand the taints? Online is clear now on the taint. Okay, so now let's do one thing. I have given an example saying that GPU nodes, high GPU resource, that meaning high level nodes, powerful nodes. So what I do is assume that my worker node one is GPU node. Which one? GPU node. See, first taint the what Dinesh? What happened? Please open one worker node. Taints we will see. You open. You can open yourself while doing the practicals, right? Edit node. Do we have any taint? Do you have any taint here in this node? Answer is no. We don't have any taint here. Okay. We will taint it now. We'll taint it now. See here. So first taint the GPU node. GPU node meaning I'm just giving an example as what? GPU. That meaning high level node. Okay. To repel force that do not require GPU resources. That meaning here kubectl get nodes, and then I'm tainting one node saying that hardware is equal to what? This name can be anything. Key value name can be anything. So I'm giving a key as what? Hardware, and then value as GPU. I'm saying here no schedule. Yes or no? But any deployment, okay, now see here. Did I put any taint here? Did I put any tolerance here? So if I put any tolerance, if I don't put any tolerance here, can you tell me, will my pods will go here? Answer is no. It clearly says no schedule. Guys, if any manifest file doesn't have any tolerance, then it will not scheduler. But if you create a tolerance called hardware is equal to GPU, then it will come and sit here in this node. Got the point? Got the point? Should we do it now? I'll show you practically. See. So first let's get the nodes. kubectl get nodes. So let's first taint it. You choose it. Which one you want me to taint? First or second? Okay, let's go. Command kubectl taint nodes. Which one? You want this PF? So go here, and then what is the key you're giving? Hardware value is GPU. Sorry. GPU. And what's the effect you're saying? No schedule. No schedule meaning strictly it will not schedule there. Tainted. So now, Dinesh, you can go and edit now and see in that node the taint will be there or not. Let's see. kubectl edit node. Which one? This node. We come down. It went up. Where? Taint. Do you see this here? Taint effect is no schedule. What's the key value I'm giving? Hardware and then GPU. So any pod which is coming with this key value, then only he will come here. Otherwise, this node will not accept any pod without these labels. Okay, Dinesh? Okay. So now let's go and do one small deployment test. So, okay. So let's go and do we have any deploy here? Okay. So I call it as vi taint, taint.yaml. Our normal plain deployment. Do we have any tolerance here? Taints will be done for the nodes. Tolerance for the pods. Do we have anything here? Now let's run kubectl. What's that? Create -f taints. Now get pods. Pods are running. This pod is running. Now tell me, this pod will be running on which node? D1 na BF? Logically, yes or not? Let's do. Understood? Because we have not given any the tolerance. Got the point? Online, you got the point? So if I go and add the tolerance now, huh? So should go and delete it first? kubectl, kubectl, delete hyphen f, which one? Taint. So kubectl, should I clear so that you can see? kubectl get pods hyphen, okay, pods, terminate, let it terminate. So now, meanwhile, what I do, I'll add the tolerance now. So this is the tolerance I need to add. Vi taints. So I'll remove this entire thing and then paste it. See the tolerance in the bottom. Understood? It's matching now. So this pod will created where? D1 na BF? D1 BF. BF. Should we do it? Because it is matching the tolerance or not? Okay. So kubectl create hyphen F. Okay. So now get pods. Okay. It should create it on BF, right? Names are matching. Hmm? So we taint it, right? So we added the nice hardware GPU, right? Yeah. Hardware GPU. So actually it should come up. There is no logic behind this, or somewhere we are doing the mistake. kubectl, edit node. Which one? This BF, right? Effect hardware GPU. We have the taint. Mm. Sometime it caches also. Oops. Did I put capital letter? No, hardware is GPU. Correct only. kubectl, apply half an F, and then taint. So kubectl So get parts -o white. So it is going to df only, d1 only. There is nothing here in the events. They will not be. Everything is MB deployment not found. This is not. What's the command? Describe command. So effect should be. It has 3 effects basically. It has 3 effects for taints and tolerance. Karthik, check 3. What are those 3 effects? Somewhere I read, right? One is preferred schedule, right? Mm. So I saw this happening multiple times, but that's fine. So you try to do it. Let's see if you are getting that things. Otherwise, we'll try to find out. Okay. But you all understood the concept online? Something, some pair, some space, something will be there. You try to do it nicely and see whether you are able to schedule it on the particular work or not. Hmm? Online is clear till here. So here, remember, this taints and tolerance has 3 fields. One is, yeah, it will work. One is no schedule. Another one is preferred schedule. Another one is no execute. If you have put this preferred schedule, then it will go to the any of the worker node. But if you put here no schedule, so if the label matches, then directly it will go and put it into that worker node. There is nothing else technical there. Logically, it should go and put it inside it. Okay, fine. Try to do it. If not, we'll check it again. Online is this clear till here on the scheduling parts? Can I get CC clear till here, everyone, please? Okay. So now let's go to the another interesting topic. Helm. What's that? Helm. So online put in the chat, Anna, what is the topic? Helm. So what is the package manager for Red Hat? Huh? Yum. Which one? Yum. What is the package manager for Ubuntu? APT. What is the package manager for Kubernetes? Helm. Which one? Helm is nothing but it is just a package manager for the Kubernetes. So using Helm, we can deploy, we can install, we can deploy the applications using this Helm. It's just like a package manager. How you are installing yum install -y nginx, yum install y something like this. Similarly, for Kubernetes, we have the package manager called Helm. We have, we didn't remove that. Uh-huh. So kubectl edit node, which one? BF? D1, right? So we have labeled, yeah, we have this, right? Okay. And then we'll deploy it. kubectl create -m. Which one is that? Taint. So kubectl get pods -o white. And still on D1. It is supposed to be on D1 or B1 VF. It was supposed to be on VF, right? Somewhere it is caching, yeah. I saw this when I was doing this. Just check it once, okay? Uh, let's do one thing. Get paint. So hardware, GPU, no schedule, right? So there are get nodes. So here cube CTL edit node. So BF. So BF has the paint, right? So let's remove it. Okay. So now if I run, does it create the pods? Yes or no? There are no taints. If you put the tolerance, nothing should happen, right? Yeah. But put it in D1. There is no logic there, Dinesh. If I put it in, okay, let's do one thing. There might be space issues, right? Okay, like this. Okay, so do we have any taints now? We don't have any taint, right? So let's put it in the D1. Let's see. Because get nodes, right? And then I'll put it in D1, tainted. There might be a chance that here I might have done some mistake, right? Okay, now it is tainted. So if I kubectl, what is that? Create -f, which one? Taint. So already deployment apps is already exist. Huh? Okay, so what I do here first, delete -1 taints, and then I'll create the taint. So kubectl get pods -o white. So when we say no schedule, so that means it will not schedule there. Huh? Uh-huh. No, no, no. So why? So I tainted to which one here now? Hmm. Get pods. It is BF. Where did I taint it? D1. So it should match, it should go there, right? So when it says no schedule, then it will not match and then go to the second one. Okay, done. Okay, leave it. Don't bang your heads on it. Okay, so let's do one thing. What you do is you try to play with it when you're doing it. Okay, and let me know once. No, schedule is not there. There is no, what do you call? You'll see it here. Delete hyphen F taints. So VI taints. Guys, there will not be any schedule. The effect is only here. There, no, this is not good. This is not correct because there is no effect called schedule. We have only three things, three effects. One is schedule, another one is preferred schedule, another one is no execute. So we need to put only these two. Guys, you try to do all these things. Okay, let's move on. So we'll get back on this. Don't worry. You try to do it. So, but you understand the concept. Whenever it is tainted, it will go there. Otherwise, it will not go. Simple as that. Okay. So, as we have the cluster running, I want to teach you one thing. Okay, guys, please concentrate this concept. Helm concept. What is that? Helm. So Helm is a package manager. Say that Helm is a package manager. So if you want to install anything, so we can use this Helm in the Kubernetes to install, deploy the packages or applications. So here we have something called charts. Say that. Charts. What we have here? Charts. Charts is the collection of manifest files. What is that? Charts is a collection of manifest files. So we use Helm. So we use Helm and then so we use charts to deploy or install any application. Helm charts. Charts has manifest files. So if you want to install anything, we need to have charts. If you want to deploy, we need to have charts. And what does the chart contains? Manifest files. Okay. So in this Helm and this Helm written in Go programming language, you don't have to worry about that, right? And then what we have is Helm repository. How we have a Docker Hub? So like this, we have something called Helm repository. Say that. We have Helm repository. So if you go here and then type Helm repository, so you'll see that this artifact hub is there, no? This is the repository. So you can search the package, for example. So today, now I'll be going and teaching you something called Argo CD. What is that? Say that. Argo CD. CD meaning continuous deployment. So here, what is the continuous deployment tool that we used before? Jenkins, no? So Jenkins, we use Jenkins in order to deploy continuously to the resources, wherever it is, in Docker, in EC2, in wherever it is. So which is the best tool to do this continuous deployment in Kubernetes? So Jenkins is not the recommended one to use for the Kubernetes. So for this Kubernetes separately, there is a tool called Argo CD for the continuous deployments. Argo CD. Say that. Online, put in the chat now. Argo CD. And then this is the Argo CD is a tool or not? So we need to install that Argo CD in our Kubernetes. And I'll be using Helm to install this Argo CD now. Understood? So you need to remember all the steps here. Those steps, I put it here clearly. What we need to first, let's go one by one and do it. Okay? See, it's very easy. Yeah. First of all, we need to install the Helm or not? What we need to first, we need to install the Helm. Do you see this here? So we have here in GitHub. So let's get that Helm here. Okay. And then do you see this here? Get helm.sh, this script. So we need to run this script or not? Before that, we need to give the permissions. chmod. How much you are giving? 700. You are giving the permissions. And then you are executing the shell. Okay. And if you do Helm -version, you will get the Helm version. Simple installation. Guys, simple installation Helm. So once you install the Helm, now let's go and install Argo CD. What we install? Argo CD using the Helm. Then in Argo CD, what we need to have? We have something called repository. What's that? I told you. We have Helm repository. Say that. We have the Helm repository. How we have the Docker Hub? Here also we have the Helm repository. So what we need to do is, yes, first of all, in that repository, there is a something called Argo Helm. So what we are doing, we are adding that repository. What we are doing, we are adding. So in Linux also we add the repositories, no? Distributions. In Linux also, in Red Hat, we add the repositories. Right? Similarly here also, in Helm, for the Helm, we'll add the repositories. So just take it and then add it. See, Argo has been added to your repositories. Now our Argo package is there in the repository now. So can we install it now or not? Yes. So, but before that, we do here Helm repo update. So it will just update our all repositories. So successfully got an update for the Argo chart repository. Argo CD has a charts. So we use charts in order to install our this Argo CD. So for that, and the best practice here is, in real time, whenever you're installing any new tools or new applications, new tools especially, create a separate namespace for it. Which one? Do not use default namespaces. Which one? Do not use default namespace. So you need to use separately namespace for the Argo CD. What's the command to create a namespace? kubectl create ns and then what? Argo CD. That is what? Create namespace. And then we'll install in that namespace or not? We'll install the Argo CD using Helm. We'll install in the particular namespace. So let it install. So after installing, you're getting everything inside the namespace. So come on, baby. No problem. Installation has been succeeded. And then, guys, kubectl get all whatever is there inside the namespace called Argo CD. Get it. Argo CD. So these are all the things that our Argo CD got created automatically through Helm. What are it? Created so many deployments. It created so many replica sets. It created something called jobs also here. It created these many services. It created these many pods. Whatever the Argo CD contains, if you want to deploy this manually, that's it, gone case. For that reason, we use Helm charts in order to install the Argo CD applications. Right? Helm is not super good things. Like, if you want to deploy or install anything in the Kubernetes, so we'll use the Helm. I would say whoever is using Kubernetes, they will be using what? Helm. So did we install it or not? After installing, what we need to do is we need to expose our Argo CD server to the outside. We need to create a service or not? With what type we are creating? Load balancer. So if I run this command, a load balancer will be created for this Argo CD now. See. Okay. Got created. Now you want to see the load balancer or not? So there is a command here in order to see the load balancer. So for that, you need to install something called jQuery. Say that. JQ meaning here basically it will just go and fetch the query from your information. If you have some information, it will go and just try to get the required information. Let's say we have a lot of file. lot of JSON data or whatever data. So exactly if you mention any key there, it will go and fetch the data. So that is the jQuery. It's a small package. Let's install this package. Once you install it, and this is the command where you get the load balancer name to find out the load balancer name. So let's see here. Okay, you got the load balancer here. Guys, no sir, why you want to use JQ? I don't want to use JQ, sir. Then what you do is simply you just run the first till here only is fine. See now. If you run this, it gives the bloody big stuff. Out of this, how do you fetch your load balancer name? That's the reason why I install JQ. Otherwise, go and if you have a very good eyesight, so go here and then do you see the load balancer name here? So to find out from the big file, we use what here? jQuery. JQ. So guys, here we have our load balancer or not? So our ARGOCD setup is done here now. Yes. So let's go ahead and then put it over here. Boom. And welcome to Argo CD. So this Argo CD that you know that what is that octopus? Huh? That is a symbol for Argo CD. So this is for let's get stuff deployed. This Argo CD main job is only to what? Deploy. What that to what? Continuously deploy. That meaning CD, continuous deployment. We cannot do any integration. We can do integration little bit, but mostly we'll use for what here? Deployment. So what's the username? So by default, the username is admin. What's that? See here. So the default username is admin. So to get the password, you need to use this command to get the password. Okay, this is a password you got. And then go here, put admin and then password. Sign in. And this is your Argo. Yes, it's open source. This is the Argo CD. See here now. This Argo CD need to deploy the application or not? This Argo CD need to deploy the application. So Argo CD need to what? We need to have the manifest file. How good you are in writing the manifest file and put it in GitHub. Where? So here also I have the GitHub. In our GitHub. There is a repository called AR deploy, Argo CD deploy. What's that here? And here I kept one small manifest file, deploy.yaml. Can you please see it and tell me this is your known thing or not? What is here? Deployment, mobile banking, and then this is this one, and then here service, and what type here? Load balancer, and also it has a notepad. And how good you are here in the writing this, put it here. So I already have my deployment.yaml file here in my GitHub. So what we need to do is now you need to configure, you need to create a new app. What did you create here? New app. Let's create a new app. And then app name, HDFC Bank. Okay. Project name, select the default. Sync policy. What is it here? Sync policy. Sync policy, here I put it as automatic. That meaning whenever you do any changes in the GitHub, automatically this Argo CD will pick it up and then deploy the new changes. That is a continuous deployment, right? Why you want Jenkins for Kubernetes? So this Argo CD is super easy to do the deployments for your Kubernetes applications. So here select the automatic, and then here source is there, no? Here I need to put what here? I need to put the GitHub URL. So go to our GitHub, get our URL here, put it here. Path dot slash, let it go into the root of this. What is the path here? Dot slash. What's the path here? Dot slash. And cluster URL, we have our Kubernetes cluster by default selected. And which is the namespace that we are using? Default namespace. So guys, now the deployment will happen. No, where do you do all this deployment? In your default namespace. And where you want to do the deployment? And in this Kubernetes cluster. That's it. So now I'm canceling it. You tell me how to create. Sorry, we didn't expect this. New app here, SDFC Bank. Project name, right. Sync policy, automatic. And then repository URL, git path dot slash. Cluster URL, selected. Namespace, default. That's it, guys. And click on here, create. That's it. If you click on create, do you see this? Automatic got deployed or not? Guys, do you see this here? Automatically got deployed. All automatic pods getting deployed. HDFC Bank, sir, this one app got created. Mobile service got created. Replica sets got created. And the pods are also running. If I go here and then do kubectl get pods, all are running. Go into the model. How many pods are there now? How many are there? 4 pods, right? Do you see? 1, 2, 3, 4 pods. Just in case, if I go ahead here in the deployment.yaml and if I edit it and then change this 4 to 6, okay. And if you want to change if you want image change it and then commit and see what will happen here. So sync. Last synced 2 minutes ago. So it should sync it. So it will sync automatically. We have selected the automatic, right? Sync. It will sync. If not, if you click on here, sync automatically, it will sync. Let's see. Synchronize. Now it is syncing here. Now do you see what's got created? Right? So if you go and remove that, whatever the modification that you have done, everything will get automatically get modified here. Delete, update, application deployment, everything can be done through this Argo CD. Online. Online, is this clear? So if you delete it, if you do the modifications, so guys, everything you can do it from here. From here also, see, if you go in, can you delete the pod from here also? Yes, you can delete it. You can delete the, you can just try to explore whatever it has. So application it has, you can modify the application if you want. So everything can be done through this Argo CD. You can refresh it. You can delete it. Rollback. What is here? History and then rollback. So now previously, how many pods were there? 4. So if you want to roll back, just go ahead and then loading. And do you see this here? Rollback. Once you click on rollback, what will happen? So auto syncs need to be disabled in order to roll back to occur. So if you click on here, OK, and then a rollback will happen automatically. So that meaning it will come back to what here? How many parts again? 4 parts it will come back. And clear? So now it is syncing. So it will just terminate those 2 parts. So you can do it is only for the deployments here. There's nothing much here. Okay. You understand? And please try to do this Argo CD, because in coming projects, I will be deploying our Kubernetes application using Argo CDs only. Clear? Online, is this clear? Okay. Online, everyone clear? All right. So by this, we have successfully completed Kubernetes. Labs, yeah. Yeah. A lot, much deeper on Kubernetes. We don't have any topics left, right? And then I want you to do a lot of practice in this Kubernetes. And then the notepad that I have given has all the information with the descriptions inside it. So if you want to clear the interviews, if you just go through my notepad, it will be super sufficient. You don't need to go here and there. Just go through it, all those things, and then we can hit it. And tomorrow, we go with what? Monitoring. It's a very one day small topic. We go with what? Prometheus and Grafana. We see it's very small topic. Yeah. So what we do is we'll just go ahead and then set up how to set up Prometheus and Grafana in this Kubernetes. We'll set up the cluster again, and then how to monitor our Kubernetes cluster used through Prometheus and Grafana. We'll see it. Okay. So after this Prometheus and Grafana, we'll go with the last tool of the course, the Terraform. Which one? Terraform. So day after tomorrow, Terraform, I want you to be ready with the developer mindset. Till now, it's different. Terraform is completely different. Okay. And this EKS, yes, we will do the project separately. Kalyani, please end it, sir. My kid is waiting for dinner. Say you disconnect this meeting and go, Kalyani. Right. Say sorry to your kid. Okay. So is this clear, guys? Okay. So please complete all these practicals, and tomorrow we'll go with yes, Ranjan. We'll go with the Prometheus and Grafana. Okay. So can you get the final CC for today, please? When is your DevOps batch starting? So guys, there will not be any separate DevOps batch anymore. For your batch is special. For that reason, I took only DevOps. I'm not ending tomorrow. Don't worry. We still have projects. Okay. We still have projects. We'll be doing it. Okay. Yeah. Okay. Can you give the final CC for today, please? Yes, I'll share the interview questions. Don't worry. So that is all for today. Let's connect tomorrow with the next topic. Until then, take care, guys, and see you tomorrow. Good night. Bye-bye.